Welcome back to computer science classes, session 38. Topic example of queries. Example of queries in relational algebra. Relation database design. Relation database design using ER diagram. So both topics are there. So which comes under chapter 6, relation data model and relation algebra. So here the first one is called examples of queries in relation algebra. So examples of queries in relation algebra, so it has so many different types of queries. So in general, the same query can be stated in numerous ways using the various operations. Using the numerous operations. Okay, fine. So here, first one is called query 1. What is meant by query 1? So here, retrieve the name and address of all employees who work for the research department. Retrieve the name and address of the employees who work for the research department. Retrieve the name and address of the employees who work for the research department. This is a query 1. So I take some points here or syntax here. So one employee is working in one department that is called as research department. That is the best example. So research department. So D name is nothing but depart name. Department name is also called as research. Research is one of the department included in which refers for only the particular employee, because each and every employee working in so many different types of different departments. But here I will take an example. Here the employee is working in research department. Okay, that is called as research department. D name is called department name is equal to research department. Research employees. Research employees less than research department at department number is equal to department number of employee. Department number of employee. So once query that tells research employees less than research department at D number, department number is equal to department number of employee. Result, third one, that shows in result, that shows father name. So next L name, last name and address, research employee. Result where father name or F name or L name, address, research employee. This is called as query 1. Okay, once again I will repeat. Query 1 is nothing but retrieve the name and address of the employees who work for the research department. Okay, so here research department D name is equal to research of department. Research employees less than research of department, D number is equal to department of employee. Result less than F name, L name, address, that shows research employees. So here next query 2. What is query 2 here? For every project located in staff order list, the project number, the controlling department number and the department manager's last name, address and birth date. Query 2. For every project located in staff order list, the project number, the controlling department number and the department manager's last name and address and date of birth. So that shows with syntax. For example, staff order is nothing but underscore projects, project location is equal to staff order of project. That is called as query 2. because for every project location in staff order list the project number, the controlling department number, and the department manager's last name, address, and birth date. Staff order projects less than project location is equal to staff order of project. That is called as query 2. And then query 3. Find the names of employees who work on all the projects controlled by department number 5. Find the name of employees who work on the projects controlled by department number 5. Find the names of employees who work on all the projects controlled by department number of 5. So here department projects syntax, department projects or project number less than project number close SDNum is equal to 5 projects. So here find the names of employees who work on all the projects controlled by department number 5, which are controlled by department number 5. You see, departments projects P number less than P number is equal to ST number is equal to 5 of project. Okay, that is called as query 3. Query 4 tells make a list of project numbers for projects that involves an employee whose last name is Smith, either as a worker or a manager of the department that controls the project. Make a list of project numbers for projects that involves an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project. Example, syntax Smith, ESSN, employee Smith or employee manager, okay fine, SSN, SL name is equal to Smith of employee, Smith of ESSN less than SSN of SL name is equal to Smith of employee. That is called as query 4. Query 5. What is meant by query 5 here? List the names of all employees with 2 or more dependents. Query 5 that tells list the names of all employees with 2 or more departments. So T1 SSN, common number of departments, close, less than ESSN, at count dependent underscore name dependent T2 less than serial number of departments is equal to 2, because employee with 2 or more dependents is 2TI. Okay, T1 less than SSN, common number of departments, close, less than ESSN, at count dependent underscore name of dependent T2 serial number of departments is equal to 2 of TI. So next, query 6. Retrieve the names of employees who have no dependents. That is called query 6. So here retrieve. It's again once again, suppose if we are storing details of number of employee details using like serial number, employee ID, employee name, employee father name, employee mother name, employee address, employee contact number, employee resignation. These are some points. Totally, the whole information will be retrieved. The names of employees who have no dependents. That is called as query 6, because there is no dependence here. Query 7 tells list the names of manager. So how many managers who are working in the particular company. List the managers. We have at least one dependent. List the names. List the names of managers who have at least one department. List the names of managers who have at least one department. Okay, that is what has query 7. So find totally some examples of queries in relational algebra. So it has totally 7 queries. Query 1 that tells retrieve the name and address of all employees who work for the research department. That is called as query 1. Query 2, for every project located in Stafford, list the project number, the controlling department number, and the department manager's last name, address, and birth date. Query 3, find the names of employees who work on all the projects controlled by department number 5. And then query 4 is there, make a list of project numbers for projects that involves an employee whose last name is Smith, either as a worker or as a manager of the department that controls the project, because each and every manager is always control each and every department. Okay, na? Fine. So the query 5 that tells list the names of all employees with 2 or more dependents. Query 6 is there, retrieve the names of employees who have no dependents. Okay, and then query 7 is there, list the names of managers who have at least one dependent. So totally 7 queries are there. So that is called as the example queries in which are available in relational algebra. Okay, fine. So next is called relation database design using ER diagram. Relation database design using ER diagram. So here what is the explained form of ER? ER is nothing but entity relationship diagram. Entity relationship diagram that represent how data will be flow from one place to the another place. The relation word is developed by EF code because ER diagram that contains entities, attributes, relation. Entity is a real world object because it has a weak entity. Entities depend on another entity. So entity is always represented by rectangle symbol. Weak entity that represent a rectangle symbol contains within another rectangle symbol. Attributes are there. Attributes means the set of properties of entity. That is called the attribute. That attribute is always denoted as ellipse symbol. And the relation symbol is there, that is called as diamond shape. So relation represent relationship between two entities. So the diagram that shows how the relation will be flows from one place to another place with the help of entities. Okay, that is called as relation diagram. I means a entity relationship diagram. Okay, fine. So here, suppose if you want to, okay, fine. 7 step. Suppose if you want to create or construct any model or diagram, so then we have 7-step algorithm to convert the basic ER model construct into relation. Basic relation construct into relation. So here we have totally so many steps, totally 7 steps are there. That's why each and every step is very important here. So that step 1 tells mapping of regular entity types. Mapping of regular entity types. This is one of the first step. Mapping of regular entity types. So what is meant by mapping of regular entity types? For each regular entity type, create a relation R that includes all the simple attributes of E-called entity relations. Each tuple represents an entity instance. So what step 1? Mapping regular entity types means what? For each regular entity type, here that shows the entity type because entity is nothing but a real world object. Create a relation, or relation is nothing but or that includes all the simple attributes because set of properties of E called entity relations. Here E called entity relations. Each tuple represent an entity instance. So here Each tuple represents an entity instance. Second one is called mapping of weak entity types. Second one, mapping of weak entity types. So what is meant by mapping of weak entity types? For each weak entity type, create a relation R and include all simple attributes. Creating all simple attributes of the entity type. As attributes of R include primary key attribute of owner as a foreign key attributes of relation. Okay, so here mapping of weak entity types means already weak. What is meant by weak entity? Entities depend on another entity. For each weak entity type, create a relation R and include all the simple attributes of the entity type as attributes of R, including primary key attribute of owner as a foreign key attributes, because key is nothing but context switching area, context switching of database design. Okay, that is called as mapping of weak entity types. Third one, step 3, mapping of binary 1:1 relationship type. A mapping of binary 1:1 relation type. 1:1 relation type. What is meant by 1:1 relation type? 1:1 relation type. What is meant by 1:1 relationship? Because for each binary 1:1 relationship type, identify relations that correspond to entity types participating in R. Okay, step 3, mapping of binary 1:1 relationship types. For each binary 1:1 relationship type, identify relations that correspond to entity types participating in R. That is called as step 3. Step 4, mapping of binary 1:n. So 1:1 relationship is there, 1-to-many relationship there, 1-many-to-1 relationship there, many-to-many relationship there. But mapping step 4 that identifies the mapping of binary 1-to-many. 1-to-many means 1-to-n means 1-to-many relationship types. For each regular binary 1:n is nothing but 1:many relationship type. That is called as step 4. Step 4 tells mapping of binary 1:n relationship types for each regular binary 1:n relationship type. Next, step 5. Step 5, mapping of binary m:n, many to n. Mapping of binary m:n relationship types for each binary m:n relationship type. So here mapping of binary m:n relationship types for each binary m:n relationship type. Suppose if you want to create a relation of S, create a new relation S. Okay, that is called a step 5. Step 5 is mapping of binary m:n relationship types for each binary m:n relationship type. Create a new relation of S. Next, step 6. Step 6, mapping of multi-valued attributes for each multi-valued attributes. Please come. It is mapping of multi-valued attributes for each multi-valued attributes. Because in attributes it has so many different types of attribute. Single attribute is there, composite attribute is there, multi-valued attribute is there. So here the step 6 tells about mapping of multi-valued attributes for each multi-valued attribute. Suppose if you want to create a new relation, primary key is the R. Okay, primary key of R is the combination of A and K. Because suppose we have two tables, A table name is A and second table name is A. The primary relationship R, because that shows the relationship. Relationship, it means what? Relationship between two entities. Okay, fine. If the multi-valued attribute is composite, include its simple components.